Okay, let's get started. It's 11:30. Good morning, everyone. It's still morning. My name is Camil Samaha, and today we are going to cover a lot of information. So without any delay, let's just go ahead and jump in. At a high level, I'm going to talk about client-side encryption, and by client-side is not necessarily the physical location. It's actually when you do encryption in your code, in your application, and whether you leverage AWS services to help you with the key management, or you do the key management completely on your own. We're going to cover both topics. We're also going to talk about server-side encryption, where AWS automatically encrypts and manages the keys on your behalf. And we'll spend some time talking about the different key management alternatives available to you for data at rest encryption in AWS. Before we jump into the services like the key management service and CloudHSM, I'm going to spend a little bit of time on an encryption primer, so we're all have the same baseline. Typically, you have a key that is generated either by hardware or software, and I need to make sure. Here we go. Sorry about that. We've got your symmetric key. And in data encryption, typically symmetric keys are preferred when you have an arbitrary data size and you are looking to do the encryption in a where performance is important. Symmetric keys are the preferred approach. That symmetric key is generated either by software or by hardware. And you take the symmetric key and you combine it with a crypto algo like AES, and you encrypt your data to get the ciphertext or encrypted data. And you take that encrypted data and you store it. It's fairly straightforward, no magic there. But what do you do with that symmetric key that you use to encrypt your data? You can put it, do you store it in the same location as your encrypted data itself? That's not a very good idea. We refer to that often as data encryption. So you really want to stay away from that. A best practice is to actually take that unencrypted data and encrypt it itself using what we often refer to as a master key or a key encryption key. So once you have that encrypted key, then it is perfectly safe to put that encrypted key with your encrypted data in your durable storage. But then what do you do with that master key itself? You can iterate the process and build a key hierarchy, or what we refer to sometimes as envelope encryption, and encrypt that key again as many times as you want to. But ultimately, you're going to reach a point where you're going to have a clear text encryption key that you're going to use to be able to unfold the whole process over again to get back to your data. So there are key considerations that you want to take into account, no pun intended there, when you're talking about your key hierarchy and developing a strategy for encryption and key management, whether it's in the cloud or on-prem. Where are those keys stored? Do you store them on-prem? Do you store them on AWS? And where are those keys used? So are you going to use them in your code, in your application, on hosts that you control? Are you going to put them on code, in your code on an EC2 instance? Or are you going to So a lot of those questions need to be answered before you can formulate a strategy for managing your encryption and your keys. Other key consideration is who has access to use those keys and who has access to manage those keys. And we're going to try to address some of those issues today in those talks. All right. So what are some of the options you have available on AWS? Well, you can start at a range where you have, you encrypt your own data used in code and use your own key management infrastructure. You can encrypt your data in your code and leverage some of the AWS services to help you with a key management function. Or you can leverage AWS services to automatically do the encryption on your behalf and manage the keys on your behalf. There's also another option that's not on the slide. You can have AWS do the encryption for you using your own keys as well. And we'll talk about that use case with S3. Okay? So first, let's talk about client-side encryption. And like I said, client-side doesn't necessarily mean it's on-prem. It's in your application using your code. All right, typically, you'll have your application either running on-prem or your application running in an EC2 instance or instances, and you encrypt the data, and you send that encrypted data to store in your storage solution of choice on AWS. Okay? So let's look at that in more detail. You start with, let's say, the case where you have your application running on-premise. You have, in order to encrypt the data, you're going to have to get a key from somewhere. And we refer to that as your key management infrastructure. So your application queries your key management infrastructure to get the key to encrypt the data. And it uses your application has a crypto module to actually go ahead and encrypt the data. And then you send that encrypted data over to AWS to store. You have full control of your keys. And in order to decrypt the data, you have to provide your keys to be able to make that data useful again. Alternatively, you can have your application hosted in AWS. And in that case, you have the option to go back to your on-prem key management infrastructure to get that data key encryption key to be able to encrypt your data before storing it on either S3 or EBS or DynamoDB or your preferred choice. Or you can have your key management infrastructure running inside of AWS. In both cases, it's important to note that the data can only be encrypted using your keys that you fully manage. Okay? So I'm flying through these. This is giving you an overview, and I really want to get to the meat of the talk, which is talking about KMS and CloudHSM. So let's talk about server-side encryption. And in this case, similarly, you'll have your application either running in your own data centers or running in AWS. And you want to send that data over a secure connection leveraging HTTPS. All our service endpoints support HTTPS. And then you will be able to leverage the services that do provide server-side encryption, which automatically encrypts your data on your behalf. And those are S3, Glacier, EBS, Redshift, and RDS. Now with S3 and Redshift, you have the option to have your data encrypted or not. With Glacier, it's encrypted by default. And for the RDS for Oracle and RDS for Microsoft SQL, that leverages transparent data encryption, which is available with those database packages. Okay? So I just wanted to show you how simple it is to enable server-side encryption in this case in S3. If you use the console, it's primarily just a checkbox. Like any feature or service in AWS, everything is available through the API. So you can select server-side encryption through an API call. What that really means is that could be leveraged by third-party applications to provide this feature or this option to you. And if you're familiar with, if you're a Mac user with CyberDuck, or if you use Cloudberry on the Windows platform, you're more than likely familiar with this option. It's just a checkbox, and the application encrypts makes sure that server-side encryption is enabled. Okay? Now with S3, you do have two options with server-side encryption. One is you encrypt your data using AWS Managed Keys, and I'm going to talk a little bit about how that works. Your data, you pass it along to the S3 service using a secure connection with HTTPS. The S3 service will create a data encryption key for each object. So it's a separate encryption key for each object that is uploaded to S3. And then we use that symmetric key with AES 256 to encrypt the data and then store the data. So the symmetric key itself, we use the S3 Master Key to encrypt that data key, and then we store that encrypted key with the encrypted data in the S3 storage fleet. Okay? And it's all done transparently and automatically for you. So the key itself, the master key, is fully owned and managed and protected by AWS and the S3 service. Now let's talk about the other option with S3, which is server-side encryption using client or customer-provided keys. You're going to start with your key, and you're going to pass that along with the data to the S3 service, and that's done through an API call, and you provide the encryption key along with the data. The S3 service uses that key to encrypt the data, again using AES 256, and then that data is stored in the S3 storage fleet. Now the question, well, what do we do with that key that you provided? The S3 service will delete that key. So we don't have, in this case, a key stored with the data in the S3 storage fleet. I think it's very hard to see because of the lights. If you have questions, if you don't mind holding them till after the talk, because we have so much information to cover. And I'm going to stay over here for 10 to 15 minutes, and I'll be more than happy to answer any questions. So we delete that key, and what that also means that in order for you to retrieve your data, you need to make an API call to S3 and include your data encryption key with the call so that the data can be decrypted and returned back to you. Okay? So we've talked about how we can make your encryption job a little bit easier using a lot of the features available in AWS. But what about that box in the dotted lines for the key management infrastructure? What can we do to help in that area? And this is where we're going to talk about one of our newest services, which is our key management service, which I'm personally very excited about. And I know from talking to partners and customers, it's been gaining a lot of traction, and it's been extremely popular to date. With AWS Key Management Service, or in short, KMS, it allows you to create, use, and manage your master keys using a fully managed service, KMS. You can leverage that using your own applications and your code using our provided SDKs. And we have several services that are fully integrated with KMS, such as S3 and EBS, and Redshift and RDS. Right now, it's available in all commercial regions. It was very recently added to the US GovCloud region as well. So KMS is widely available, and you could leverage it today in all the commercial regions. Okay, so let's talk about how the KMS service works. All right. You have your client, and it will send an authenticated request of the KMS service for a data encryption key is the first step. The KMS service, in turn, generates that key, and then it will pull a encrypted master key or customer master key from the KMS service, uses the KMS crypto module. And by the way, we have a white paper that I strongly recommend if this is an area of interest, that we make available that details the KMS crypto module and all the gory details that you want. It's available to download through our website, and I'll be happy to point you to that white paper afterwards. So the KMS service pulls the encrypted master key from durable storage, decrypts it using the KMS crypto module, and then it uses that master key to encrypt the data encryption key and passes both keys back to the client. So the client uses the plain text encryption key to encrypt the data and store the encrypted master key with the data. So when it comes down time to decrypt that data, the client would request from the KMS service to decrypt that master key and then use that to decrypt the data. Okay? So the question now comes, well, what if that client is one of the integrated services that work with KMS? Similar to what I just talked about, it's a two-level or two-tier hierarchy leveraging envelope encryption. You have the data key that encrypts and decrypts data. You have a master key that encrypts those data encryption keys. And that comes with a lot of benefits. So you talk about performance and management. Think of a scenario for S3 where we have billions of objects, and you think about key rotation. It'll be a lot easier to rotate a smaller number of master keys than it would be to try to rotate billions and billions of resource keys or object keys. So leveraging envelope encryption gives you that benefit. And that's also true using your own application to leverage KMS. It's also a two-tier hierarchy for key management. Okay? And now in this slide, I wanted to show you how the console looks when you're trying to create, use, and manage your master keys. The services themselves that are integrated with KMS come with default keys, master keys available for you to use when you first get started. But you can obviously create your own keys, and in this case, you'll see there's an alias that gives it, human readable description that would mirror your data classification and categorization policies. So you could have a separate master key for confidential data, a separate master key for highly confidential data, and then another one for less sensitive data. And then you have full control who has access to use those keys and who has access to manage those keys. So with the KMS service, it gives you the full flexibility of creating, using, and managing those keys and limiting access to those keys. Very simple interface using the console, also available through the API for automation. Okay? This is the case if you are wanting to enable encryption with EBS. It's very simple again, it's just a checkbox. But you'll also notice there's a drop-down menu where you select the master key that you wish to utilize to, for encryption of that EBS volume. And it'll give you a human-readable description and alias as well. Okay? Very simple, also available again through the SDKs to be able to automate the process. All right? So, as I just mentioned, you have full control over who has ability to create the keys, who has the ability to use those keys, and who has the ability to manage those keys. But even more importantly, every API call made to the KMS service is logged and available through the CloudTrail service. So the KMS service is fully integrated with CloudTrail, which means it gives you full visibility and audit capabilities into your key management infrastructure. So I know when I talk to compliance and security people, they get quite excited when they see the level of visibility available and through KMS. Okay? So still that question, all right, great functionality, but what about the master keys that I create? How does AWS secure those keys? Well, there's several things that come into play here. The first one is the plain text master keys are never stored in persistent memory. Okay? Second one is the separation of duty. You have your operators or administrators who are managing services like S3 and EBS that leverage KMS. They do not have access to the systems that generate or manage or do any operations on the master keys. And in reverse, the KMS operators or administrators do not have access to the service team systems to be able that use those keys and process the data. Now, what about the KMS operators that have access to the KMS systems? In that case, we do have it's a pretty revolutionary approach. Quite simple, but if you think about it, it does remove the risk of where you have one rogue employee that might either intentionally or unintentionally compromise the keys. Any operations against active systems that handle or process those keys require those API calls require two operator signatures. So basically, you have a quorum of two or more people to be able to do any operation on those KMS systems that handle your keys. And all of that is documented and verified in the SOC 1, as well as our public white papers. Okay? So now you have KMS. So we've talked about your ability to do encryption in your code using your own preferred approach for managing those keys to completely leveraging KMS, which takes you almost to the point where you do have full control of the keys and control of access to those keys. And even with the quorum-based approach, some organizations or agencies want to go even further than that. And that's where CloudHSM comes into play. Now, HSM, which is a hardware security module, I'm just going to do a quick overview of HSMs in general. They're typically physical appliances that have special characteristics, and they are in effect tamper resistant or evident. So if there's any tampering that happens, you know that somebody tried to tamper with the physical device. And some also go beyond that, where it goes beyond just being able to detect tamper. They will wipe or delete the master keys versus risking compromising of the keys. Another very important feature of HSMs is a separation of duty, where you have your administrators that have access to the physical device. They can do very limited set of functions, primarily things like assigning an IP address to the appliance. And then you have your security, and those administrators have no visibility and no access to the keys or any cryptographic operations on the HSM. And then you have your security officer that has access, or security officers that have access to those, to the keys and the crypto operations, but don't have access to the physical device itself. And a lot of those appliances come with third-party certifications that comply with security standards and government standards. Now, so what about CloudHSM? With CloudHSM, it's an actual physical HSM appliance. And actually, it's the SafeNet Luna HSM that physically resides in one of our data centers close to your virtual private environment in AWS. You have dedicated access to that physical appliance. And those appliances are made available to you inside of your VPC, or virtual private cloud, which gives you additional benefits to be able to leverage security groups and subnet ACLs to limit access to those to the HSM in your VPC. Another important point, as I talked about HSMs in general, you still have that separation of duty. AWS has physical access to the box, but we do not have access to the keys or the crypto operations inside the box, while you have full access to the crypto and the keys running on the HSM. Okay. So let's talk a little bit more about the service. It is currently available in several regions worldwide, and I'm not going to go repeat them, but it used to be 5. We recently added 2 more, I believe, in the last 2 to 3 weeks. We also make it very easy for you to get started. We have actually a CloudFormation template that will launch your VPC environment, that will launch your subnets and the security groups, and actually launch an EC2 instance with the SafeNet client application pre-installed on the EC2 instance. So you can launch that template. It will create that stack for you automatically with the SafeNet client already installed. And we also provide several application nodes to help you to integrate with third-party products like Oracle databases or Microsoft SQL Server or EBS Volume Encryption with the SafeNet Protect V, and also it integrates with the Linux Apache. We have notes on that to help you get started. From a compliance point of view, the CloudHSM is included in both our PCI DSS as well as our SOC compliance packages. So if you're a compliance officer, you can certainly request access to those packages and verify the claims. Okay. So we recently also launched with CloudHSM support through the command line interface. What that does is it allows administrators to more easily automate a lot of the processes that they had to go through to manage those HSM boxes. We also have a public API and SDKs available to allow self-provisioning, so it makes the provisioning process a lot simpler than it used to be, as well as appliance administration functions as well. From a logging point of view, CloudHSM is also integrated with CloudTrail, so any API calls made to the CloudHSM service they are all logged in CloudTrail and available for auditing. And you also have the capability to send syslogs to your syslog collector. So you can configure that inside of the HSM so you can collect syslog information as well. Okay. Now I'm going to talk about one particular use case, and that's leveraging the CloudHSM to do EBS Volume Encryption. In this case, you would have the SafeNet Protect V client running on an EC2 instance, and that client will encrypt the I/O as it moves from your EC2 instance to, as the data is written to the EBS volume. And also that client supports pre-boot authentication as well. So you can encrypt your boot volumes. Now the Protect V client leverages the Protect V manager, which is available in the marketplace, and the virtual key secure infrastructure available from SafeNet to leverage the key hierarchy for the data encryption keys. And the Cloud Protect V manager in turn uses the CloudHSM to store the master keys. So with this solution, you're able to encrypt your EBS volumes using your keys, and those keys are, you have full control of those keys. So there's just another alternative based on your risk profile and based on your encryption requirements, where you can go from fully client-side encryption in code, as well as your own on-prem cloud management solution, a key management solution, all the way to leveraging CloudHSM to do encryption and have full control of your keys. So this is wanted to do a quick comparison at a high level between CloudHSM and AWS KMS. CloudHSM is a dedicated appliance that meets several government standards like FIPS 140-2 Level 3, and also common criteria, EAL 4, I believe. And then you have full control of your keys and the applications that use those keys. With KMS, we build upon the HSM foundation, and we give you full control of who has access to use and manage those keys, and also full auditability of the operations made against the KMS service. Okay? And you can use the SDKs to leverage the KMS service, or you can use the AWS services are fully integrated with KMS that I mentioned previously, like S3 and EBS. All right? Now, one thing I didn't touch upon, and a lot of what's listed in this table we've already talked about, but I tried to use as small a font as I could and make it still visible, and that's in the price row under the AWS Key Management Service. and that's the $sign. With a KMS, it's relative to the on-premise HSM or the cloud HSM solution, it's definitely a lot more affordable. And those prices are published online and available for everyone to see. So one major advantage of KMS is the price tag that comes with it as well. Not only from and that's not including the additional overhead of having to manage the infrastructure and operate it continuously. This is primarily just from the operational point of view. Okay. So we have KMS and we have CloudHSM. What about alternatives to those approaches? Well, if you're not familiar with our marketplace, you really need to get familiar. It's a very, very healthy ecosystem that is available. And particularly in the security area, there are several partners. I only have very few of them listed here. The list is quite extensive that you could leverage. And the advantage of using the marketplace is the licensing models that are available. You can go from one pay by the hour, so you can experiment and try a lot of these products. And some of them make them available with bring your own license, or they make it available you pay by the month, or you pay for the full year. So whatever procurement requirements you have, there's a lot of flexibility in the marketplace that you could leverage. Now, from the key management and encryption perspective, what's available in the marketplace, we have, again, several vendors that play in that field and that are available. I have 5 of them listed. Many of them give you the ability to integrate with S3 and EBS and RDS. And they all have something in common, that they give you full control of who has access to the encryption keys. And several of them also give you the option of storing your master keys either in your on-prem in your data centers or through a SaaS offering that the vendor provides. But in addition to that, what if you want to keep your key management infrastructure close to your applications for performance reasons and for durability and high availability reasons? Is that even possible with these vendors? And the answer is yes. You can integrate them with the CloudHSM offering. Okay. So we have a lot of resources available for you to leverage. I know I mentioned earlier the KMS crypto module. We have a white paper specifically going into the details on the crypto module. If it's not listed in here, you can see me afterwards. We'll find it online, and I'll be happy to point you to it. But there's a lot of material out there that will get you as deep as you want in the encryption options that you have on AWS. And if you have any questions, I'll be happy to take them. It's really hard to see who's raising their hand, so I'll ask you to come up front, and I'll be able to take your questions and try to answer any questions that you might have. I know somebody tried to ask a question earlier here, so please come up, and I'll be more happy to take your questions.